Hello, and welcome to another video of tutoring with Leah Cremona.
Today, I'm going to be going over some questions that involve dilution and evaporation. So here we have the equation that we're going to be using for these questions. M, for both sides, indicates concentration, and V indicates volume. Here, volume can be milliliters or liters. It doesn't really matter. Just make sure that when you're doing the calculations that the numbers have the same unit. And of course, M here is concentration. So here in these questions, we are talking about solutions. So solutions, as you might know, are made up of the solute and the solvent. The solvent will be the one that is in greater amount and that the solute is dissolved in. The solute is the one in less amount. So here, to demonstrate these ideas is example 1. For these questions, we will use this equation, and what you have to know is that in the question, there will be 3 of these given, and you have to find the 4th. One will indicate initial, and 2 will be the result. So for example 1 here, it says that 5 milliliters of water were added to 7 milliliters of a solution, which ended up having a 5 molar concentration. What was the initial concentration? So right here, using this equation, we see that we must find the initial concentration. So this will be in question. At first, the solution had a volume of 17 milliliters, right? Because 5 milliliters were added to 17 milliliters. So in the end volume was 17 plus 5, which is 22 milliliters. And the resulting concentration after 5 milliliters of water were added was 5 molar. So here we have the unknown initial concentration times 17 milliliters equal to the end concentration times 22 milliliters. Now we must find the initial concentration, which we do by dividing both sides by 17, so that 17 can cancel out on the left side and leave us alone with M1. Canceling out 17, and so M1 is 5 times 22, all divided by 17. The result here is 6.47. And we know that is the concentration represented by M. So the answer is that before dilution, the solution had a 6.47 molar concentration. Example 2. What is the final volume when 15 milliliters of 0.2 molar hydrochloric acid is diluted to 0.05 concentration? So right here, diluted means that we're adding water. So here, we know the equation we have to use. M1V1 is equal to M2V2. So let's fill in the values here. Right here, we're looking for what is the final volume. So final volume, V2, is the question. So here, 15 milliliters of 0.2 concentration is diluted to 0.05 concentration. So this is the end concentration, 0.05. And we know that here, 15 milliliters of 0.2 molar concentration was diluted. So here's the initial volume, 15 milliliters, and the initial concentration was 0.2. Now we have the equation 0.2 times 15 is equal to 0.05 with an unknown value for the final volume. Now, because we're solving for V2, we divide both sides by 0.05, which leaves us alone with V2 is equal to this right here. And V2 is 60 milliliters. So in order to dilute 15 milliliters of a 0.2 initial concentration to a final concentration of 0.05, 45 milliliters of water must be added, yielding a final volume of 60 milliliters. Example 3. What was the initial volume if 1.5 molar solution ended up at 2 liters and a concentration of 1.47 concentration? So here we see that the end is a volume of 2 liters and an end concentration of 1.47. The initial volume is the question here, since this is not given. And here 1.5 is the initial concentration. So the concentration here went from a larger to a lesser number, which of course would be expected when you dilute a solution. So the equation we end up with is 1.5 times the unknown initial volume equal to 1.47 times 2. To isolate the initial concentration, V1, on the left side, we divide both sides by 1.5 in order to cancel out 1.5 from the left side. In the end, we are left with V1 equal to this. After putting these numbers in a calculator, V1, the initial concentration, ends up to be 1.96, and that will be in liters. Example 4. What is the initial volume if 2m of HNO3 was evaporated to a 3m solution of 100 milliliters? So again here, we are looking for initial volume. However, the key word here, evaporated, means that the solution is going to decrease in volume. Evaporation means that there is a loss of some of the liquid there. Some of the solution went away. In this case, we know that the part of the solution lost was the solvent. And it still doesn't change the number of moles in the solution. We still use the equation M1V1 equals M2V2. And here, we're looking for initial volume again. So here's the question. And the initial concentration is 2. So it was evaporated to result in 3m. Final concentration is 3. And final volume is 100 milliliters. The equation that we end up with is 2 times V1 equals 3 times 100. To isolate V1 on the left side, we divide both sides by 2 in order to cancel out 2 on the left side. This will lead to V1 equal to 300 divided by 2, which is 150. And that unit will be in milliliters. So as expected, the initial volume before evaporation was greater than was the end volume after evaporation. Example number 5. Find the final concentration if 10 liters of 3.5 m HBr was evaporated to 2076 milliliters. Once again, we use the equation M1V1 is equal to M2V2. And also we have evaporation again, which means that we are losing some of the solvent. Because it says to find the final concentration, we know that M2 is the question. It's what we're trying to find. Now, here we see that there are the unit of liters and milliliters. To work these two together, we must have a common unit. So we can either convert this number of milliliters to liters, or we can convert this number of liters to milliliters. It's your choice. In this case, I'm going to convert 2076 milliliters to liters. 1000 milliliters is 1 liter. Or you can say that 1000 milliliters are in 1 liter. Doesn't really matter. You just have to know that this is the standard for milliliters and liters. In this case, I'm going to use this information to cancel out milliliters and get liters. So here I'm going to multiply 2076 milliliters as one fraction. Any number over 1 is just that number. This fraction times here, this information. To cancel out the same units in multiplication, they must be on different levels. So one must be on the top and one must be on the bottom. So here, I know that 1000 milliliters would go on the bottom, leaving me with 1 liter. So because one is on the top and one is on the bottom of the fraction, I can cancel out the unwanted unit, leaving me with the wanted unit of liters. Now, 2076 divided by 1000 is 2.076 liters. So now we know that 2076 milliliters is equivalent to 2.076 liters. Now I can work with these because they're in the same unit. Here, the 10 is the initial concentration. And V1, 10 is volume, so 10 goes here. And the initial concentration is 3.5. The final volume is 2.076 liters because it was evaporated to this volume. Now the equation that I have now is 3.5 times 10 is equal to the unknown M2 times 2.076. To isolate M2 on the right side, I have to divide both sides by 2.076. Now this cancels out, and I'm left with M2 equal to 16.86 so the final concentration is this value. So the general trend here is that when you dilute something, the concentration decreases, and when you evaporate it, the concentration increases. Again, dilution is the addition of water to the solution, and evaporation is the loss of water from the solution. In summary, remember that you have to write out the equation M1 times V1 equals M2 times V2. And then read the question very carefully and plug in the known values, knowing that you have to find the fourth and unknown value. Another thing to note here is that you might see the equation M1V1 equals M2V2 represented as McVc equals MdVd. It works the same way. Pick one side as the initial values and one side for the resulting values. So D, you can think of it as the diluted version. This is the concentrated version, and this is the diluted version. Personally, I prefer 1 and 2, which just shows the before and after. Because sometimes instead of dilution, as we saw in the previous examples, you will have evaporation. Because the equations work the same way, it is your personal choice whether to use 1 and 2 or C and D.
Thank you so much for watching this video. Remember to subscribe if you're new. And please let me know in the comments if you found this video helpful or if you have a different way that you solve these types of questions.